Day 57, MCT4C, lesson 6.2, day 3, subsection 85, code 2, no, it's just day 57. This is the third day of polynomial equations. And the 3-minute review says it's last day solving polynomial equations, but we haven't seen one like this before, right? The whole idea here behind this equation would be to somehow get it so we had brackets, factored brackets equals zeros, and each of these would give us the roots, right? The solutions, x equals whatever. But you know, right now there's no zero there, so we might be tempted to think about making this a zero on this side and doing some simplifying, and that is in fact what we do, even though we haven't seen one like this yet. That's what we do. I'm going to subtract 6x from both sides, add 8 to both sides, and then I can see that it's equal to 0. And now this one looks like one from yesterday. It doesn't look like I can use grouping, so I'm going to use the factor theorem. I'm going to call this f at x, and I'm looking for a factor that when I substitute in, it's going to be 0. I try something nice and small. 1, 2, and 4, and -1, -2, -4 work, but I try something nice and small, and I should find it right away. I do. This is it. So therefore, x minus 1 is a factor. And it's a long division here. Subtract. We are so used to this now, holy. Knowing that it's got to work out in the end, right? It's got to work out. I get 0. And so then I'm going to say that this equation, notice I'm not going to work with this equation. We used math to say that this equation and this equation are equivalent, right? We just expanded and used algebra to make this equation equivalent to this one. So now we can work with this one if we would like to. And so I'm going to say star becomes and then that part I can factor. Easy trinomial. And I see my solutions then, right? X equals 1, x equals 4, x equals -2. Collect those up in a set, and everything looks awesome. That's the solutions. And it asks me to check your answer with a graphing calculator. So how do we do that? Well, there's actually 2 ways. There's 2 ways to do this. One is to take that equation right there and graph y equals that. Okay, and that's essentially the technique that we used yesterday. See, there's the one from yesterday. And what was the equation? I think I can just switch this one. X cubed minus 3x squared minus 6x plus 8. And I graph it. Right? Zoom 6 will give me the standard, and look at there. And I could use my second function calc to find the zeros, but I've checked it. It's all good, right? What's that one right there? Just for fun, so we remember how to do this. Left, right, guess. It jumps right there. It's 1, right? It's 1. That's the version that we we knew that was 1, right? Let's see, take screenshot, and I'm going to put that there, paste that down. So over here, I'm going to make some notes. So TI-83 check. So the first way is I'm going to put y1 equals that graph, and then look for zeros. looks for x-intercepts, right? And that's this way. But there's another way. I could have actually, and we saw this, a while ago when we did exponential functions, right? I could write the left side and the right side in, right? I could go y1 is equal to x squared times x minus 3, and I could go the right side is 6x minus 8, which is just a line, and see where those cross. And I should get the same solutions. They're equivalent equations. So let me see. X squared bracket x minus 3, and then down here, what was it again? It was 6x minus 8, and I'm going to graph that. There's that one, right? X squared. And look, there's a solution there at x equals 1. Notice that I can't really see it, but I could change my window settings so that I could see more of the graph. I'm going to squish in the x settings and zoom out on the y settings so I can see all of my graph, all of my solutions. One there, and one there. Can I convince you that that is the same x values, 1, 4, and -2? Sure I could. Sure I could. I'm going to copy that in there, by the way. So what are we looking for there? And how do we get it? I'll remind you of that. Is we're looking for the intersection points, right? Not the zeros, but I'm looking for the intersect. And remember, the on-screen instructions are slightly different. The first curve is there, the second curve is there, and then a guess. Maybe I'll go find this point this time. That's the point -2, -20. So, well, hang on. I thought it was a 0, right? It's equal to 0. No, that's the intersection point. And when we're looking for the intersection point of an equation, we only care about the x values, right? And so the x values here are x equals 1, x equals -2, and x equals 4, just like we had it before. All right, another 8-minute, 3-minute review, but also another fairly quick lesson. So we'll charge on. No, I'm going to split this into 2 videos. We had a long 3-minute review. I'll split this into 2 videos, and I'll pick it up in part 2 in just a second.